So I will be presenting my PhD work, From Simulation to Reality and Back Again, a hybrid approach to optimize the compliance and validity of responses in ESM studies. So experience sampling method, or ESM, is a very popular method to understand what people do, feel, and think during their daily activities through self-reporting. And it has numerous applications. For example, in healthcare, when researchers want to understand and assess the effectiveness of a healthcare intervention, or in psychology, where a specific psychological phenomenon is to be studied, and also in human technology interaction and user research. And notifications, as reminders, play a key role in the experience sampling method, because us humans have limited attentional resources, and we need reminders to self-report. These reminders are usually set at random moments, based on some events, or at some fixed intervals. In turn, they can increase the engagement of self-reporting, they can reduce reactivity, they can increase ecological validity, and also they can decrease retrospection. However, there's an adherence issue in this type of research, because evidently participants usually drop out after a few weeks. That's because usually the notifications come across as intrusive or interruptive. On top of that, in the experience sampling studies, there is typically a low intrinsic motivation and also instrumental attitude towards participation. That will result in a low response rate and ultimately low quality research data. That is partially because that these notifications are not really adapted to individual behavioral patterns. That means that us researchers need to be mindful about when we're sending the notifications, what is it that we're sending through them, through which channels, and through what devices. In other words, through personalizing time, content, and modality, evidently, it's possible to create less intrusive notifications. That would result in higher response rate, and in turn, we can have better quality research data. But then again, the challenge is to adapt notification delivery to day-to-day behavior to maintain engagement in self-reporting at the right time with the right content using the right modality of delivery. To further study adaptable notifications, I created Experiencer. Experiencer is a software developed for commodity-level smartwatches to do experience sampling studies. It allows remote configurations through JSON files. It is possible to record different types of sensory data. And it also allows and offers different types of interfaces for different types of questions. It's also openly available and open source. So with that, I have done up until now 7 experiments in total, and in total 12 weeks, about 350 participants, and I was able to deliver more than 10,000 notifications. There I wanted to really test the difference between different notification delivery schedules based on the sensor data that can be collected from the watches, to assess the impact of adaptation on the response rate. And I realized that context matters. In other words, I found significant difference between the response rate to prompts delivered at different contexts. And by context, I mean time of the day, the location, the level of physical activities, and different other information that can be gathered from the sensors of the watches. I also realized that there is no one-size-fits-all solution, because the response behavior is highly subjective and context-dependent. What can help to provide kind of a more individualized personalization and adaptation is machine learning, because it can learn the opportune moments of delivering notifications over time. However, this is also prone to some issues. For example, a sampling bias. So machine learning algorithm can become highly personalized over time, but that means it might miss a few or a lot of moments during one's life, which is against kind of the goal of the experience sampling studies. And that would in turn result in low quality research data, but it might maximize, let's say, the adherence. On another note, the learning agents at the beginning of the learning process, they don't know much about their target audience. So they act randomly, they send notifications at random moments, and they will indeed learn over time what is the opportune moment. But because in the beginning of such a process, those notifications are random, they might come across as intrusive. So then that might result in quicker dropout before the machine learning models had learned anything. And that problem is referred to as cold start. So to address those issues, I had this idea to simulate response behavior, because I thought that with such a simulation, we can predict the convenience of an experience sampling strategy. So let's say the experimenters, the researchers could adjust and test their protocols in simulation and then apply it in the wild. On the other hand, it can also provide some prior knowledge to machine learning models to prevent the early dropouts. That is called a warm start, or also pre-training. So to facilitate that, I created Sapphire. Sapphire simulates human response behavior to notifications. It can combine theories, heuristics, and machine learning models to create virtual participants that imitate response behavior to notifications. In turn, the researchers can estimate adherence to research protocols for researchers before applying it in the wild. Also, as I said, it can provide a simulation environment for machine learning agents to avoid the cold start. It is also open source and freely available. For example, we could integrate heuristics related to motivation and urge to self-report with the memory accessibility pertaining whether somebody's going to perform a task at hand or not, in this case self-reporting. I could also train a machine learning model based on the previous contextual data I'm gathered and predict whether people respond in a specific moment to the prompts or not. With such a combination, we could ultimately simulate the human response behavior similar to what we have seen in our historical data. To further kind of verify the simulation, I compared the real-life data with the simulated data and basically calculated the similarity measure to see how similar the outcome is. And also, I monitored and analyzed to make sure that the data generated by the simulation is explainable by the theories, specifically the psychological theories behind it. In this last year that I have left on my PhD, I have planned to do a experience sampling study specifically targeted at the elderly population to also assess their response behavior and how is it different from my previous cohort, which were mostly student and staff. And also try to see if I can mine their daily behavioral patterns. I have also planned to more ESM studies with the built environment PhDs at the TUE, because there the building is equipped with different types of sensors and I can gather more contextual data. Lastly, I would like to do also a few interviews with the domain experts to actually evaluate the flexibility of Sapphire in terms of incorporating different types of theories and heuristics. Thank you.